This is my Arduino data collecting project. I used a solar panel and a temperature sensor to collect data over time onto an SD card um, in order to answer a question that we've been having in our apartment, which is where we put our houseplants. So we have two living rooms. One faces south, our living room window, and it has good sunlight from about the morning time until 2:30. And then the other room is Josh's bedroom, which faces west. And it has a little window in which it can get light through, but it can be obscured by leaves and branches in the building. But you can see it's a little bit brighter in here in the afternoon. And so the question I wanted to answer is, what time during the day should we transition the plants from the living room to Josh's bedroom in order to maximize sunlight intake for the plants? And so one thing that I had to do was figure out which resistor would maximize power, because power is equal to voltage squared over R. So I could have a variety of resistors, such as a decade resistance box that Dr. Sharp helped me with, and see what the voltage is from our solar panel over the variety of different combinations and see which one maximizes power. And so the nearest resistor to the one that maximizes power at almost 2 watts is a 68 ohm resistor. And so some important lines of code in the project is this analog read function that takes in the voltage of the solar panel, and that we then convert this sensor value to a float called voltage that makes it go from 0 to 5 volts instead of 0 to 1023. And then I added a delay function so that one sample is taken per second because we're going over long time spans. So you can see on day one in Josh's room, it was already 6:30, so by 7:30 there was barely any sunlight, and that time the temperature didn't vary that much, so that's why the line is a bit thick. Day two, I started at 1 o'clock in the living room. You can see there is a good amount of sunlight in the afternoon all the way up until about 2:30, and then there's just you'd better utilize the panel to move it into the other room because it's only getting 1.5 volts right here by 2:30. All the temperature sensor was always placed next to the window gap so that outside air could come in, and for some reason there was a big increase in temperature for a little bit. In the evening at 4 o'clock that day, I moved it to Josh's room, and you can see instead of the 1.5 volts we get at 2:30, we're getting 4 volts way up here, and it's going, but then right around the afternoon, there's these trees in the way. And then 6 o'clock is pretty low, as you saw from day one. Finally, in day three, the temperature goes up by 7 degrees, and it's a 7-hour interval. So instead of minutes, I actually did it in terms of hours from noon. And then the voltage, you can see there is a good amount of voltage starting at about 2 o'clock. It starts at 1.5 volts, so you can kind of pick up where it leaves off in the living room. And it just grows and grows and grows and grows. But right around here, 4:30, as seen in the other one as well, there are a lot of obscurities. So overall, the conclusion is around 2:30 p.m. I should move the houseplants from the living room to Josh's bedroom in order to maximize sunlight. My solar panel, which I bought off Amazon, it was $10. And it is a 1.25 watt, 5 volt, and 250 milliamp module. And I easily clip it on. And it sits upon a mount that I designed in Tinkercad. And I designed it to have a 35-degree angle, as well as have these little things to stop it, to have it so that it can slide down in it, but still stop it, and have the cord so that it can go underneath, out the back. The reason I chose 35 degrees is because at our latitude, at 35 degrees. The best tilt at our time of year for 35 is 35-degree tilt angle for our latitude. So this is kind of like a solar panel latitude to tilt angle conversion. But I mean, overall, I took a solar panel class last year. 35 degrees is recommended for us, like a static, locked-in, fixed tilt system. And so I measure the voltage based on the solar intensity with this panel, as well as take a temperature reading, which is another, I don't know, it could be beneficial for plant life, have not too chilly of weather. And the voltage from the solar panel crosses this resistor, and then here's the high end, here's the ground. And so with that resistor that I found to be maximizing the power, we have pretty good voltage right there that I can measure over time. And then finally, we have the SD card all hooked up to the Arduino, all the pins working correctly. And so just to give you a little live demo of what it's like, it'll initialize testing, and now it is doing the time and the sample, the temperature and the voltage. So you can see the voltage get, oh shoot, you can see the voltage get brighter as I put the lamp closer and closer. It is an LED lamp, so it doesn't really give that much heat because I'm trying to conserve energy. But this is it working in real time. I can't really show you what it's like in the long-term data setting because I use it with this power bank. And so if it's connected to this running off of that power, then I can't really show you it collecting data. But I do give the okay that it is printing data with that little blinky.